This is a special type of case that you do come across. Suppose I have g of x equals x plus 3 over x squared minus 9. And we want to find the vertical, horizontal asymptotes, all that stuff. So the thing is that, yeah, I can factor and all that, or I can set equal to 0 and everything, but you got to be careful here. Because if you notice, well, there's something similar here, right? Well, remember, we can factor the denominator, difference of squares. So x squared minus 9 factors to x minus 3 and x plus 3. What happens? Cancels out. So you're left with 1 over x minus 3. So if I set that equal to 0, the denominator, x equals 3. Now, here's the thing. Yes, there's only one vertical asymptote. Now, it's a good thing we didn't set this equal to 0 and solve it because, yeah, we get two values. But the problem is that one of them actually cancels out here. So you have a vertical asymptote of x equals 3. But since this cancels here, right, that means we have a hole, so we call it a hole at x equals -3, which basically on a graph, if you have some kind of curve and say this is -3 right here, you'd have a hole. Something like that. So that's a special type of case. So then now let's graph one. So let's do a graphing one. Let me just clear the board here. So now I'm going to graph the function f of x equals 2x over x minus 1. So first things first, the domain of the function. Well, I set the denominator to 0. There's nothing I can factor here. Can't factor anything from the numerator nor the denominator. So I set the denominator equal to 0. X minus 1 equals 0, add 1 to both sides, and x equals 1. Well, that means that the domain is all real numbers except x cannot equal 1. So in interval notation, that's going to be -infinity to 1, union 1 to infinity. So, okay, we have that. Well, now we got to see if we have any vertical or horizontal asymptotes. Well, believe it or not, again, we already know we have vertical asymptotes because that's where the function is undefined. Well, the function is undefined, x equals 1. So again, I'm going to abbreviate vertical asymptotes as VA. Vertical asymptotes at x, or excuse me, asymptote is only one here. You can have more than one. You have multiple ones at x equals 1. Now for horizontal asymptote, well, I take the highest degree term here, which is 2x, and the highest degree term in this part, which is x. I divide them. 2x over x is 2. That means I have a horizontal asymptote at y equals 2. So now I can start graphing this. Now, this can get a little tricky, but what you do is you make a table of points, and you want to find any x and y intercepts, and then pick points that are below your vertical asymptote value and above it. So basically, you want to pick values such that 1 is in between them. So for instance, like, okay, I can do, let's find the x-intercepts or the y-intercepts. So if x equals 0, well, that gives me 0 over -1, which is just 0. And let's say I pick a point, that's below, pick another point below 1. I don't know, let's do -1. Well, that'll give me -2, -1 minus 1, that's also -2. So then -2 over -2 is, so -2 over -2 is just 1. And then let's pick 2. If x equals 2, you get 4 over 1, which is 4. And then let's pick 3. That gives me 6 over 2, which is 3. So now we could, well, actually, let's do one more point just to be sure. I don't know. We have 2 positive values. Let's do 2 negatives. So let's do -2. So that'd be -4 over -3, which would be 4/3, or 1 1/3. So let's plot it. So I know I don't have the most room here. I apologize, but I'll squeeze it in down here. So now we can plot. Well, this is 1 right here. And it's a dashed line. This is x equals 1, vertical asymptote there. Y equals 2, so 1, 2, like that. This is my horizontal asymptote at y equals 2. Now we plot our point. So we have the point 0, 0, the point -1, 1. So I'll say this is -1. And 2, 4. This is 1. I'll say this is 2. 3, 4. So the point 2, 4, dot, dot, dot. It's like right in there. I know it's not the best spot. 3, 3. Okay, so I have 3. So I have 3 here. I go up. It's right about there. And -2 4/3. So -2 4/3 is 1 1/3. So it's going to be like somewhere there. So now, well, I got to connect it. So what is that going to look like? Well, it's very, very close. And it's going to go down like that. And then this, I'm going to have it go down like that. And again, it gets very, 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 very close, but never actually touches. So this is the graph of f of x equals 2x over x minus 1. And that will do it for today. I hope this video helps, and have a great day, everybody. Bye-bye.